right, so this lesson, we're actually going to be looking at two different lessons about how to prove that triangles are congruent. Now, there's four ways to prove that triangles are congruent. Side, 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 angle, side, angle, and angle, angle, side. These are four ways. We're actually going to learn more, but these are the four for the lesson today. So the first one, postulate 4.1, is what's called the side-side-side postulate. We abbreviate that SSS, all right? And here's what it says. If three sides of one triangle are congruent to three corresponding sides of another triangle, then the triangles are congruent. So it's going to look something like this. If I can show that side AB is congruent to side DE, if I can show that side BC is congruent to side EF, and if I can show that side AC is congruent to side DF, I have three sides of one triangle congruent to three corresponding sides of the other. If this is true, then I can say that triangle ABC is congruent to the other triangle. Now, to name the other triangle, I have to make sure that I match up their corresponding vertices. So, for instance, if you notice how A is between the single mark and the triple mark, D is between the single mark and the triple mark and the second one. So I know that A has to match with D. All right. Sorry, that's an ugly D. I know that B has to match with E. And I know that C, between the second and the third mark, has to match with between the second and the third mark, F. And I can say that these two triangles are congruent by side, side, side. A second way to prove that two triangles are congruent is to use postulate 4.2, which is called the side angle side postulate. We abbreviate that side angle side, or SAS. Notice how the A for angle is in between the two S's for sides. And here's what the postulate says. If two sides in the included angle of one triangle are congruent to the two sides in the included angle of another triangle, then the triangles have to be congruent. So let's pick two sides in the first triangle. Let's say that we know that AB is congruent to DE and AC is congruent to DF. These two corresponding pairs of sides we have shown to be congruent. In order for us to be able to use side angle side, we have to know that the included angle simply means the angle between the congruent known sides. So in the first triangle, there would be angle A, and in the second triangle, there would be angle D. We know that in order for these two triangles to be congruent, those two corresponding angles must also be congruent. We can then say that triangle ABC, and again, we want to match up our corresponding pieces, is congruent to triangle DEF. And our reason here would be by side angle side, or SAS. All right, so here's an example now that says, how would you complete this proof? So I start with the given. They tell me that JK is congruent to LM, and that's given. There it is right there. They also give me that JM is congruent to LK. My reason for this would be it's given. All right? So that's what we have marked in the picture as well. They want us to prove that this triangle JKM is congruent to the other triangle LMK. I have two options. Option number one, prove that this MK side is congruent, or prove that angle J is congruent to angle L. Now there's nothing in the given and nothing in the picture that would tell me that angle J and angle L are congruent. They say in this flow proof that Km has to be congruent to itself. Now we learned this property a while ago. Now it's really going to start to show up in our proof. And the reason why those are congruent is by the reflexive property of congruence. Reflexive. The reflexive property of congruence. Okay. So now I look at the two pictures. I have three sides of one triangle congruent to three sides of the other. All right? I now have enough to say side, side, side would allow me to say that the triangles themselves are congruent. So I would say for the first triangle, I'm just going to call it JKM because that's what they give me. And now I want to make sure that the corresponding pieces match up. So J is between the 1 and the 2 hash. L is between the 1 and the 2 hash. K is down here, but it's between the 1 and the 3. Between the 1 and the 3 would be M in the second triangle. And then M is up here in the first triangle between the 2 and the 3. So that would be the K in the second triangle, LMK. And the reason why is by side, side, side. All right? Now, pause the video right now, and on your guided notes, go ahead and try to do this problem, doing a proof from start to finish. All right? Okay, so the next thing that we're going to talk about is what other information do I need to know to prove that two triangles are congruent, and they tell me that they want to prove them congruent by side angle side. In order for side angle side to work, I have to know two congruencies of sides and a congruency about the included angles. All right? So in the first problem, what's missing is I need to be able to show that that side's congruent to that side. That side LG is congruent to side MN. And if I have that, then I can use side, side, side. Take a look at this. All right, so in this problem, what do I need to know? Well, I've got two congruencies of sides. I have a congruency of angles, but that angle isn't the included angle. All right, what I want to do is I want to say, okay, well, if I know that angle T is congruent to angle V, angle T congruent to angle V, then I can say that the two triangles are congruent by side angle side. All right? Let's take a look at these. Now, how would you prove that these two triangles are congruent? You can either use side, side, side or side angle side. In this first picture, the first thing that jumps off the screen to me is I know that AC is congruent to itself. So now I look at the first triangle. All right? I see side, angle, side. Can I match that up with the three pieces of the other triangle? Side, angle, side. I did. I'm going to make a triangle congruency statement. I'm going to call the first triangle ABC. I could have called it BAC. I can call it whatever I want. But now I have to make sure that the second one I match everything up. So I notice that in the first triangle, A has the congruency mark. So I'm going to start the second one with C. I know that B is kind of at the end of the congruency mark and one tick mark for the congruent side. The congruent angle and the congruent side is how I get to B. So if I do the same thing, I get to D over there. And then the other angle would be angle A. And these are congruent by side angle side. All right? Take a look at the next picture. In this next picture, the only thing that I know to be true is that these vertical angles are congruent. So I don't know anything about PQ and SQ. Side, side, sides out. I don't know anything about angle T and angle R. Side angle side is out. I don't have any other resource. Now some of you may be thinking this. You may be thinking angle side side. Well, here's the problem. If you use angle side side, you become an angle side side. I'll explain that more next class. So the second half of the lesson here is two other ways to prove that triangles are congruent. Angle side angle and angle angle side. The angle side angle postulate says that you have to have two congruencies of angles and one congruency of sides. And notice how the S is in between the A's. That means that the included side has to be between the two congruencies of angles. So here's what this is going to look like. Let's say that A is congruent to D. Let's say that C is congruent to F. Then the side that is in between those two congruent angles, AC, would have to be congruent to DF, in order for these two triangles to be congruent. I could then say triangle ABC is congruent to corresponding pieces D, E, F, and my reason would be by angle, side angle. Okay? Take a look at this example. I know it kind of overlaps into the next example. It says, name the two triangles in this picture out of these three that are congruent by angle, side, angle. So if I'm going to look at this, I look for angles, two angles. I got two angles in all three, but they have to have the included side. That side is included in PQR. This side in USV is not included. This side is included in VXW. So I can say that triangle PRQ is congruent to what triangle? Well, let's see. P has one mark, V has one mark. This triangle's out of the mix. All right. R has two marks, W has two marks. And then Q and X should match up. And these two triangles are congruent by angle, side, angle. All right. Let's take a look at this proof right here. It's a paragraph proof that we got to fill in a couple of things. So they start off by telling us angle LKM, that's a single mark up on top, is congruent to angle JKM. So right now I'm seeing two angles that are congruent. Got it? I go LMK, there's the double tick mark, and JMK, angle JMK, those two angles are congruent. So right now I'm thinking angle, angle. So I need some other information. There's not enough. Well, one thing that I notice is that this side, KM, is congruent to itself. All right, we just talked about that. The reason why something would be congruent to itself is because of the reflexive property of congruence. All right, so if I have two angles and the included side of two different triangles that are congruent, I can say that the triangles are congruent by angle, side, angle. All right, now I want you to have prepared for the next class this example. So go ahead and pause the video right now. See if you can prove that those two triangles are congruent on your notes paper. All right. The next thing we're going to talk about is something that's called the angle side theorem, also broken down as AAS. So angle side. If you notice, we still need two congruencies of angles. And then one side congruency, but the side is not between the two congruent angles. So let's mark this up a little bit. Let's say angle A is congruent to angle D. Let's say angle B is congruent to angle E. Now, I could either say that BC is congruent to EF, or I could say that AC, and this is the one I'm going to mark, is congruent to DF. Either one of those sides that are pairs would work. The one that wouldn't would be AB congruent to DE. Why? Because that's angle side angle. The side is included. So now I could say that triangle ABC, again, is congruent to triangle DEF. And my reason here would be by angle, side. All right? Let's take a look at this proof now. They want me to prove that these two triangles are congruent. They start off by giving me that N is congruent to S. Got it. That's given. Then they say angle NQT, that's this angle, is congruent to angle SQR, that's this angle. Why are those two angles congruent? They're congruent because vertical angles are congruent. All right? The next thing they do is they say line L bisects segment TR at Q. So here's what that's telling me. That's telling me that this side and this side have to be congruent to one another because of this word bisect. All right? Now, how do I know that statement is true? Look back up in the given. It's given. All right. So what I want to do now is, because of that statement, we said that TQ and RQ were congruent. So I'm going to say segment TQ is congruent to segment RQ by the definition of bisect. All right? I look at the picture. I now can conclude that this triangle is congruent to this triangle. My reason would be angle, angle, side. Angle, angle, side. All right, and then what I would like you guys to do is do one more proof like this. See if you can figure this out. Notice you're going to have to apply the definition of midpoint on this to help you with the proof. I'm curious to see what you guys come up with for these proofs. All right, so the last thing I want to talk to you guys about is determine whether the triangles must be congruent. If so, tell me how. All right. So if I look at this, the one thing that jumps off the screen at me is this congruency that must be shared. I know that these two triangles, triangle PMO, must be congruent to triangle NMO by, read the picture, angle, side, angle. All right, I look at this next one. I notice that angle U is congruent to angle R. I notice right away that this side is shared. So I've got a side that is shared between the two triangles. It's congruent to itself because of the reflexive property. Now, the other thing that I know is that this line, SU or US, is parallel to TR. If those two lines are parallel, then I know that these two angles are congruent. Why? Because they're alternate interior angles. So now I have two angles and a side that are congruent to two angles and a side. I know that triangle UTS, watch how I name this, is congruent to triangle R, matches with U, T, but that now is going to be S in the second triangle, and S from the first matches with T in the second. Reason is by angle, angle, side. Now, I expect that you guys are going to have a little bit of difficulty with this. We're going to follow up our next lesson by talking even more about these and getting more practice at it. Remember, what I want you to do is complete those three proofs to the best of your ability, and then we're going to start looking at them next class. Hopefully this helps. Hope you guys have a great day.